Ladies and gentlemen, I'm Yanping Huang. I come from Taiwan. It's my pleasure that I can present my research paper here. The research is a digital archive data preservation management system using iRODS architecture. This is my outline. It includes introduction, literature review, Silica data preservation system architecture, experiments, and conclusion. Concurrently, the amount of data is huge. Not only the quality of data is growing in size, but also it becomes much more and more significant issues. It increases importance to improve and maintain infrastructure service for a long time. It is very important to serious problem for use. Therefore, this study uses an automated approach in which digital policy and strategy are represented as rules, which are implemented in data grids that use iRODS middleware. Based on iRODS middleware, this study discovered the Silica data preservation system we named CDIP. The CDIP management platform offers better control of the environment and helps to deal with semantic crises, increasing efficiency and allow more effective use of symmetric resources. Why we discovered the CDIP architecture? Because the amount of digital data is growing constantly. Unfortunately, digital archives are often fragile and susceptible to data loss. Therefore, as the amount of digital information continues to grow almost exponentially, it is increasingly important to develop new ways to manipulate this data and minimize the risk of data loss after hardware failures. This paper creates an important data preservation system that uses iRODS middleware, a distributed data management system that is suitable for data grids, digital libraries, and persistence archives. In a literature review, I will introduce the iRODS history. The iRODS is an open source project that is being developed by the Data Intensive Cyber Environment Group as the successor to Storage Resource Broker. A particular feature of iRODS is the ability to represent data management policy in terms of rules. The system incorporates a rule engine, which interprets these rules and allow predefined sequence of action to be executed in particular sequence. Rule execution results in the creation of persistent data information, which can be accessed from within rules to track and control subsequent rule execution. There are two types of data grids, iRODS and the green data farm. Example of shared large files use application based on simple API for grid application to link iRODS and the grid data farm. Repeated advantage is storage technology charged in access protocol. Application means that constant upgrade to a digital preservation environment are required. Empirical research has described the minimal requirements for the preservation process required to implement archive management policy and the minimal set of preservation metadata required to validate the integrity of a digital repository. The CDIP platform provides the capability both to implement the necessary policy and to maintain the metadata requirement to manage a serious digital archive. Generally, the CDIP provides several APIs that allow developers to create their application. The CDIP platform located with a remote cloud tile moves digital archives which not being modified or which have been left idle over a period of time to the Csci platform. This framework also helps to reduce power consumption compared to more power-intensive online models such as Hadoop or the Google file system. In order to control the intention of operation and to improve the system, the digital archive data preservation management creates a multi-system and the backup systems to control the operation situation and add the mechanism. The monitor system uses the expanded NAGIS system. The NAGIS system includes a SMS model and a backup control. Consequently, the use of NAGIS monitoring service is extended to monitor the Csci platform. The combined monitor system regards NAGIS as a core to design and join various intersections of expansion and component in time. In the monitor system architecture includes the three functions of NAGIS, which are the interesting of control, increasing SMS notice machine, and over complete add machine with requirement. The component structure of the monitor system is divided into 5 layers altogether, depending on function different of each component. The first layer is MS SQL database. This controls expansion outside of the host computer service and the entire system state recorded in the monitor system. The second layer contains the relevant procedural protocol, which are used to transfer information between NAGIS core and the external link. The third layer of NAGIS core contains the core of this system. There are 5 components in this layer. In the fourth layer, the NAGIS core shows web page, figure interface, and convey the procedures that must be performed on information. The fifth layer controls the information procedure for the monitor system. The control information shows the entire system web page and the system administration receive notice information that is sent from web, Skype, email, or SMS. In the present infrastructure constructed, the resource node is stored in the Academic Sinica, Museum of Natural Science, Lithography Institute, Taiwan University, Hoggar Community of Place Museum. The resource node is shown in figure. The plan is to construct the infrastructure in every organization and to store information in the resource node. In order to support all the backup for every organization to maintain the demand directory. The disk array of 10 TB is a storage brick. In order to guarantee reliability in deposition and withdraw multiple content, more than 3 copies must be preserved. The first backup is in the local node, the second backup is in the Csci platform, and the third backup part is stored on tape for a long time. The Csci platform contains several optimized data management machines that address 3 issues to help users to manage digital archive verbally. 2 education and training courses will be offered. In the training course, users will be explained the backup system, data synchronize package, user space introduction, and the interface operation units, so that they can suggest improvement service to improve its utility. There are 3 characteristics of the Csci platform. The first, it developed reliable storage for perceived digital objects. The second, it provides well-organized information structure for effective content management. The third, it designs easy, efficient, portable, and friendly remote backup interface for users in different platforms. The CD platform approach includes digital policy and exchange. It is represented as rules, which are implemented in data grid. Research results show that hardware is expanded. The CD is upgraded and maintenance is popular. The CD platform is designed and established for a long time, present and remote backup digital content. The distributed storage were built up among 9 major data participant institutes. The capacity is extended to around 880 TB to accommodate the backup of each digital object in different sizes. The CD platform also be cooperating with National Center of High Performance Computer to establish the tape backup system. Users require a good user tool that support a multilingual interface in the CD platform. The system status must be visible and it must provide flexible and efficient functionalities. The synchronized package provides users with another option for managing their digital archive. The US-based tool includes many data manipulation functions to allow more convenient processing of data. The synchronized package can be used in combat with the OS scheduler and synchronize data automatically. The package also makes use of an email dispatch program that is able to send data synchronization record to use via email. It also includes file encryption and UTF-8 encoder conversion. In the future, we will focus on developing relation assistance programs to help users and management enhance the function convenience. The CD platform will active digital resources continually, maintain valuable digital resources, and add value to the digital service. Government and the user will join this digital content service, which will be benefit to industry and will allow the integration of policy to promote industry marketing by combining experience and promote cooperating for a long time. Thanks for your attention. It's all my presentation contents. If any question, please let me know or email to me.